Start with a price collapse in European solar panel imports and trace it back to a single production decision made years earlier inside China's industrial policy system. Build a cause and effect chain where manufacturing overcapacity quietly turns into geopolitical leverage through pricing pressure instead of traditional trade barriers. Solar power isn't being weaponized through restriction or embargo, but through relentless price deflation engineered by scale that reshapes entire energy transitions abroad. Cold and methodical, detached observation, letting industrial data and policy moves carry the weight. A solar panel landing in Rotterdam in 2024 cost less than the steel frame holding it in place. That sounds like a market miracle until you ask why the price keeps falling even when demand is climbing across Europe, India, and parts of Africa. I want to stay with that contradiction for a moment, because it doesn't behave like a normal commodity cycle anymore. It behaves like something being pushed. China now produces roughly 80 to 85% of the world's solar modules, depending on the segment you look at. That number alone is not the story. The story is how that dominance stopped being about export success and started becoming about structural pressure on everyone else trying to build the same supply chain. Around 2021, Chinese manufacturers began expanding polysilicon and wafer capacity at a pace that didn't match global installation forecasts. In plain terms, they built factories faster than the world could absorb panels. The China Photovoltaic Industry Association itself has flagged this overcapacity issue repeatedly since then. That detail matters because it removes the illusion that this is accidental oversupply. It's visible, documented, and still accelerating. Now here's where the logic shifts. When you flood a global market with a product that gets cheaper every quarter, you don't just win market share. You set the price ceiling for everyone else. European and American manufacturers don't fail because they are technologically behind in every case. Some aren't. They fail because their cost structure assumes stable pricing. The Chinese system does not. Let me say something I keep coming back to. I don't think this started as a geopolitical strategy in the traditional sense. There wasn't a meeting where someone decided, we will weaponize solar. But industrial policy doesn't need that kind of intent to become strategic. Scale alone can do the work. And this is where it starts to feel uncomfortable if you're sitting in Brussels or Washington. The Inflation Reduction Act in the United States tried to rebuild domestic solar manufacturing through subsidies and tax credits. The European Union has launched its own Green Deal industrial plan, but both are reacting to a moving target. Prices keep dropping faster than policy can stabilize local production. There's a counter-argument I hear often. This is just competition working as intended. Lower prices accelerate the energy transition and consumers benefit. That's partially true, but it ignores what happens when one supplier sits so far down the cost curve that entry becomes structurally unprofitable for almost everyone else. We saw a version of this before in rare earths. China didn't ban exports permanently. It didn't need to. Periodic tightening combined with overwhelming production capacity was enough to rewire global dependency. Solar feels like the scaled-up version of that logic, except now it sits inside the core infrastructure of the energy transition itself. And there's another layer people often miss. The Chinese solar sector is not just exporting panels, it's exporting deflation. Each new gigawatt deployed globally comes in slightly cheaper than the last. That sounds positive until you realize it compresses the revenue base of competing industries across Germany, the US, and parts of India that were just starting to scale. Here's the part I'm still not fully settled on. Is this sustained because it's efficient or because it's strategically tolerated inside China as a form of external leverage? I'm not 100% certain on intent, but the outcome is hard to ignore. Opinion-wise, I lean toward a simpler framing. Even without explicit coordination, China has stumbled into one of the most effective industrial power positions of the 21st century, control over the price trajectory of a critical global input. And the uncomfortable question forming underneath all of this is simple. If your energy transition depends on a single country's ability to keep producing at a loss-efficient scale, is that transition actually diversified or just relocated? There's more to unpack in how this feeds back into global trade policy and industrial retaliation patterns. There's a moment in every global industry where scale stops behaving like an advantage and starts behaving like gravity. Solar crossed that line quietly, sometime around the late 2000s, when China's manufacturing clusters stopped looking like competing firms and started looking more like a single, synchronized industrial organism spread across provinces. You can see it most clearly in places like Jiangsu and Zhejiang, not in headlines, in procurement data. The same chemical inputs, the same wafer standards, the same shipping patterns repeating with machine-like consistency. Polysilicon production in Xinjiang feeds ingots in Yunnan, which feed wafers in Sichuan, which end up as modules exported through coastal hubs. It's not just vertical integration, it's territorial integration of an entire supply chain. That structure matters because it removes friction. And in industrial economics, friction is where competitors survive. Let's take Germany for a second. Germany didn't lose solar manufacturing because it stopped innovating. In the early 2000s, companies like Q-cells were globally competitive. What changed was not capability, but cost convergence pressure. As Chinese capacity expanded after the 2010 to 2015 subsidy cycles, global pricing began to reflect Chinese marginal production costs, not European capital intensity assumptions. There's a report from Fraunhofer ISE that quietly tracks this shift, not as a political story, but as a cost curve collapse. European module production couldn't maintain margin even when efficiency matched. That's the detail most simplified narratives miss. Efficiency didn't decide the outcome. Cost architecture did. Now, here's where things get less comfortable to interpret. In a traditional trade war, you expect barriers, tariffs, quotas, export bans. Solar doesn't behave that way. Instead, China largely kept exports flowing. What changed was internal scaling speed. Every time global demand surged, post-COVID stimulus, European energy crisis after 2022, Chinese capacity expanded faster than demand could stabilize pricing. That creates a very specific effect. It doesn't just dominate markets, it prevents price recovery cycles from forming. And that leads to something I want to pause on. A market that cannot rebound is not behaving like a normal commodity market anymore. It behaves like a managed output system, even without centralized intent. Now, I know the pushback here. Economists from the efficient market school would say this is just comparative advantage playing out. China has cheaper labor, better logistics density, and massive upstream control. Let it win. The transition gets cheaper. But that argument starts to wobble when you look at survivability of alternative producers. India's production-linked incentive scheme for solar manufacturing is trying to seed domestic capacity. The United States is doing something similar under the Inflation Reduction Act. Yet both systems are effectively trying to build upstream resilience in a market where upstream pricing is still being set externally. It's like trying to build an aircraft engine industry while someone else controls the global price of titanium and keeps lowering it below production cost. And I keep coming back to one uncomfortable historical parallel. Not because it's identical, but because it rhymes structurally. OPEC in the 1970s didn't invent oil dependence. It just revealed it by controlling supply timing. Solar is different. There's no cartel meeting, no quotas. But there is a similar outcome. A critical input to global energy systems is increasingly priced outside the strategic control of importing states. The difference is subtle but important. Oil was about restriction. Solar is about saturation. There's also a domestic angle inside China that often gets ignored in Western analysis. Local governments have strong incentives tied to industrial output and employment. That means capacity expansion doesn't always slow, even when profitability compresses. In fact, sometimes it accelerates because output metrics matter more than margins in the short run. So when people ask, why doesn't China just cut production to stabilize prices, the answer is messy. Because in parts of the system, stability of employment and output signals can outweigh price rationality. And this is where I start to question the sustainability of the current trajectory. Not politically, structurally. Because a system optimized for relentless capacity expansion eventually runs into one of two limits. Either global demand catches up, or prices compress so far that consolidation becomes unavoidable. Right now, we're still in the middle phase, and it doesn't feel settled yet. The next layer is what this does to geopolitical bargaining power, when solar stops being just an industry and becomes infrastructure. There's a point where an industry stops behaving like a sector and starts behaving like infrastructure. Solar is already crossing that line in multiple regions, even if policymakers don't always say it out loud. Think about it in simple terms. Electricity generation used to be anchored in fuel logistics, coal, gas, oil. Those had choke points you could see: ports, pipelines, shipping lanes. Solar replaces that with manufacturing dominance upstream and installation density downstream. And China sits almost entirely on the upstream side of that equation. Now, the complication. Solar looks decentralized once it's installed. Panels on rooftops, farms in deserts, grids absorbing distributed input. But the supply chain feeding it is anything but decentralized. Polysilicon refinement, wafer slicing, cell production. These are heavily concentrated and not evenly distributed across countries that consume the final product. According to data tracked by the International Energy Agency, China controls a majority share across most critical upstream stages of the solar value chain, not just final assembly. That distinction matters more than headline market share because it defines who absorbs cost shocks and who sets marginal pricing. Let me translate that into something more concrete. If module prices drop by another 20%, which isn't unlikely given current overcapacity, it doesn't just hurt competitors. It resets the baseline assumptions for every national energy plan that assumed a certain return on domestic manufacturing investment. And this is where the story becomes less about competition and more about policy constraint. India, for example, is trying to localize solar manufacturing through phased import duties and production incentives. The United States is doing something similar, but with a stronger subsidy backbone. Europe is more fragmented, trying to balance decarbonization speed with industrial survival. All three are responding to the same underlying pressure. The global price floor is not moving in sync with domestic industrial policy. There's a subtle tension here that often gets missed in political debates. Governments are not just competing with China on technology or labor anymore. They are competing with time. Because capacity expansion in China doesn't wait for policy cycles elsewhere. Now, I should challenge my own framing a bit here. It's tempting to describe this as deliberate external pressure, as if China is actively using solar pricing as leverage. I'm not fully convinced that intent is necessary to produce the effect. What we can say with more confidence is that the system architecture inside China rewards expansion speed, vertical integration, and export absorption of excess capacity. That combination alone is enough to generate global price suppression without a centralized strategy. Still, outcomes matter even when intent is ambiguous. Let's look at a historical echo that helps clarify the mechanism. In the 1990s and early 2000s, Japan experienced what economists called industrial overcapacity pressure in sectors like steel and shipbuilding. The difference is that those were eventually contained through domestic consolidation and offshore relocation. Solar is not resolving that way because demand is still expanding globally. There is no contraction phase to absorb excess capacity. Instead, expansion keeps meeting expansion. Which brings us to a quieter but more important shift. Energy sovereignty is no longer just about generation capacity. It is about manufacturing control over the tools of generation. And that shift is not evenly distributed. One of the more under-discussed reports from the International Renewable Energy Agency points out that developing economies adopting solar at scale are effectively importing not just equipment, but embedded industrial dependency. Once installed, systems require maintenance, replacement cycles, and supply chain continuity that remains externally anchored. So even countries gaining energy independence in fuel terms are not necessarily gaining industrial independence in hardware terms. Here's where I start to get cautious with conclusions, because there's a plausible, optimistic interpretation. You could argue this is just the early phase of a global manufacturing realignment, and that eventually other regions will catch up as subsidies mature and learning curves steepen locally. That's not impossible. But it assumes that learning curves can outrun scale advantages indefinitely. Historically, that hasn't always held. And that brings me to a more uncomfortable observation. We might be watching a transition where energy diversification increases while industrial concentration deepens. Those two things can happen at the same time, which is not what most policy frameworks are designed to assume. The next layer is what happens when this pricing structure starts feeding back into diplomatic leverage, not through direct confrontation, but through dependency embedded in infrastructure planning. There's a strange inversion happening in global energy politics, and it doesn't announce itself through sanctions or summits. It shows up in procurement spreadsheets, in revised national targets, in energy ministries quietly adjusting assumptions about cost curves that no longer behave the way they used to. Solar was supposed to reduce dependence. In a narrow sense, it does. Less imported oil, less exposure to shipping choke points. But if you zoom out a little, dependence didn't disappear. It relocated. Now it sits upstream in the industrial base that determines what a panel costs before it ever reaches a port. And China sits in that upstream position with a level of dominance that doesn't resemble the classic idea of market share. It resembles something closer to price authorship. I want to be careful with that phrase because it sounds more intentional than it necessarily is. But when you look at the consistency of cost declines across cycles, 2010 subsidy build-out, 2018 trade tensions, 2022 energy shock in Europe, the price trend doesn't just respond. It keeps moving in one direction, almost regardless of external pressure. That creates a kind of strategic rigidity in other countries' planning. Take the European Union's Net Zero Industry Act. It's designed to rebuild domestic manufacturing capacity for clean tech. But its internal projections still rely on assumptions that solar module prices will stabilize at levels that support local production. If prices continue drifting downward faster than domestic scaling can compensate, those assumptions quietly break, not loudly, just structurally. And that's where my own interpretation becomes less certain, because there are two ways to read this system. One is that China has built an industrial machine so efficient that it unintentionally sets global price ceilings in a critical energy technology. The other is that the system's incentives, export absorption, capacity expansion, local fiscal dependence on output, create a form of persistent external pressure without needing explicit coordination. I'm not fully settled on which explanation is complete, but I don't think either can be dismissed. What matters more is the effect. Other countries are no longer setting the pace of cost decline in a technology central to their own decarbonization plans. And that creates a quiet dependency loop. The more solar is deployed globally, the more the world relies on the same concentrated upstream system to keep costs falling. If that system slows, the transition becomes more expensive. If it accelerates, competitors shrink further. It's a bind that doesn't have a clean policy answer. Historically, when we've seen this kind of concentration in strategic sectors, states respond in one of two ways. Either they accept dependency and optimize around it, or they invest heavily enough to recreate redundancy even at higher cost. The United States is leaning toward the second path. Europe is trying to split the difference. Emerging economies are mostly price takers because capital constraints narrow their options. But here's what I keep coming back to. Solar was politically framed as the most democratizing energy technology of the century. And at the usage level, that's still true. A rooftop system in Nairobi or Lahore is real autonomy in a way fossil fuels never offered. Yet the industrial backbone of that autonomy is becoming less distributed, not more. That contradiction is going to define the next decade more than any single trade dispute. My view is this: China didn't need to explicitly weaponize solar for it to become strategically consequential. The structure alone, scale, integration, and sustained cost compression, already produces leverage-like outcomes in global energy planning. The question going forward is not whether others can match China's output. It's whether the global system can function smoothly when one node effectively defines the price trajectory of an entire transition technology. And I'll end on a simple, uncomfortable thought. If the cheapest path to decarbonization runs through a single industrial ecosystem, then energy transition is not just a climate project anymore. It's a supply chain bet with geopolitical consequences that most countries are still underestimating. I'll leave it there.